For today, let's look at this algebra question. Given that A, B, C are positive real numbers such that the sum equals to the product, we are asked to find the minimum value of the square root A squared plus 1 times B squared plus 1 times C squared plus 1. I'm going to use two different methods to solve this question. One is of my favorite AMGM inequality, and the other one is by trigonometry. Please have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
Now, the first method is regarding AMGM inequality. So, since A, B, C are positive real numbers, we know that the sum of A, B, C will be greater than or equals to 3 times the product to the power of 1 over 3. So, the product is A, B, C, and we know that this is also A, B, C. So, this means that A, B, C to the power of 2 over 3 will be greater than or equals to 3, which means that A, B, C is greater than or equals to 3 to the power of 3 over 2. That is 3 square root of 3. And obviously, the equality holds if and only if each of the A, B, C equals to square root 3. Consider A squared plus 1. I can write it as A squared over 3 plus A squared over 3 plus A squared over 3 plus 1. And again, using AMGM inequality, with 4 terms, this will be greater or equals to 4 times the product to the power of 1 over 4. So it will be equal to A to the power of 6 over 27. And this is not only true for A squared plus 1, it will be also true for B squared plus 1 and C squared plus 1. You just need to change A to B and to C. And so, the square root of A squared plus 1 times B squared plus 1 times C squared plus 1 will be greater than or equals to the square root of 4. This is 1 over 4. So the first one will be A6 over 27. Second one will be B6 over 27. And C6 over 27. From the previous inequality, ABC is greater than or equals to 3 to the power of 3 over 2. Then this means that ABC to the power of 6 will be greater than or equals to 3 over 2 to the power of 6. That is 3 to the power of 3. That is equals to 27. And so ABC power 6 over 27 will be greater than or equals to 1. So this means that this itself will be greater than or equals to 1 to the power of 1 over 4, still 1. This will be greater than or equals to square root of 64, that is equals to 8. And again, equality holds if and only if, number 1, from here, A equals to B equals to C equals to square root of 3. And it also applies in here because A squared over 3 has to be equal to 1, which is the case for A, B, and C as well. And hence, we can say that the minimum value will be equal to 8. So this is the end of the first method. If you enjoyed this video, please like, comment, and subscribe. Now, since A, B, C are positive and the sum equals the product, then we can let A to be a tangent A, B to be tangent B, and C to be tangent C, where A plus B plus C equals to pi. For those who do not familiar with the result, I'll show you the result here. A plus B plus C equals to pi. Then A plus B will equal to pi minus C. The tangent of A plus B will equal to the tangent of pi minus C. And this actually equals to negative tangent C. And we know from formula that tangent A plus B will be tangent A plus tangent B over 1 minus tangent A, tangent B. And therefore, tangent A plus tangent B will equal to negative tangent C times 1 minus tangent A, tangent B. So this will be negative tangent C and plus tangent A, tangent B, tangent C. And we add both sides by tangent C. So we have tangent A plus tangent B plus tangent C equals to tangent A times tangent B times tangent C. So whenever the sum of three variables equals to the product, we can always treat it as tangent A, tangent B, and tangent C, where the sum of the angle equals to pi, or in fact it can be equals to odd number of pi. So when we have this nice substitution, then this is not difficult, because A squared plus 1 will be equals to tangent square plus 1. And this will be equal to secant square, that is equal to 1 over cosine square A. And therefore, let's call this as P. So P will equals to 1 over cosine A, cosine B, sine C, where A plus B plus C equals to pi. And now we change this question to the minimum value of 1 over cosine A, cosine B, cosine C. Now to solve this, we may consider cosine A plus cosine B plus cosine C and plus some magic term, that is cosine 60 degree. So by using formula, cos plus cos equals to 2 cos cos. This is A plus B over 2, A minus B over 2. And for this, it is similar. It is cos C plus 60 over 2 and cos C minus 60 degree over 2. And we know that cosine is not more than 1. So this will be less than or equals to 2 cosine A plus B over 2 plus 2 cosine C plus 60 degree over 2. Again, take out the 2, we have cos plus cos. It will be equals to 2 times 2 cosine A plus B plus C plus 60 degree over 4 and cosine A plus B minus C minus 60 degree over 4. So again, the cos is less than or equals 1. So this is less than or equals to 2 times 2 is 4. And this is cosine 180 degree plus 60 degree is 240 over 4, 60 degree. And cosine 60 degree is equals to half. So this is less than or equals to 2. And from here, what we have is cosine A plus cosine B plus cosine C will be less than or equals to 2 minus cosine 60 degree, that is half, that is 3 over 2. On the other hand, we also know that, call this is K. We also know that K will be greater than or equals to 3 of cosine A, cosine B, cosine C to the power of 1 over 3. And K is less than or equals to 3 over 2. So it means that cosine A, cosine B, cosine C will be less than or equals to 1 over 2 to the power of 3. That is 1 over 8. So with this, it will mean that this P will be greater than or equals to 8. And the equality holds if and only if cosine of C minus 60 degree of 2 equals to 1. That is C equals to 60 degree and A equals to B. So it means that P equals to 8 if and only if A equals to B equals to C equals to 60 degree. And in that case, it means that all of the value of A, B, C must be equal to tangent 60 degree. That is equal to square 3. Again, we prove that P equals to 8 is achievable. And therefore, the minimum value is equals to 8. So this is end of the second method. Please let me know in the comment which method you like the most. Now this is end of today's lesson. I'll see you again next time. Bye bye.